Let's answer part A. So here we write y in terms of x. So as we can see from the diagram, this side length is y, and we have another length of x. So when we add these two, we will get x plus y, and this equals half of this length 16, which is 16 over 2. And this means we can solve for y from this equation. That is x plus y equals 8. So this implies y equals 8 minus x. So now we have written y in terms of x. Let's determine the volume of the box. For the volume of the box, we need to understand the length, width, and height of the box. So when we fold this cardboard along the dotted lines, this will become the length of the box, and this side length will become the width of the box, and this length a little bit, the portion which is being cut off from the cardboard, this will become the height of the box. So the length of the boxes, we have to first determine the length. Since a square piece of x centimeter is cut from two corners, the length will be the total length, which is of this side, that is 10 minus sum of these two side lengths, that is x plus x is 2x. So basically L equals 10 minus 2x. So I'm going to write down the volume of the box as length times width times and height. So now we know that length equals 10 minus 2x. And then we determine the width, which is exactly y. So I can replace for y, which is 8 minus x. And then the height of the box is x. So we can distribute this and put it in a simplified form. So this equals 10 minus 2x. First, I distribute the x into the two terms inside the brackets. So 8 times of x is 8x, and minus x times of x is x squared. Let's once again FOIL this out. So this is 10 times of 8x, and then 10 times of negative x squared. Then we have negative 2x times of 8x. We then have negative 2x multiplied with negative x squared. We will simplify this. So 10 times of 8x is 80x, and 10 times of negative x squared is negative 10x squared, and then negative 2x times 8x is negative 16x squared, and finally we have negative 2x negative x squared. This will be positive 2x cube. We will put this in the decreasing powers of x. So first we put this term, that is power of x. So we can write down this as 2x cube. And then we have the like terms, negative 10x squared and negative 16x squared. When we add these together, we get negative 26x squared. And finally, we have plus 80x. So we were able to show that the volume function is 2x cube minus 26x squared plus 80x. Let's answer part B. So here we first determine the value of x such that the volume is maximum, and we will also have to justify that by the sign of the first derivative of the volume function. So first I'm going to write down this volume equation as a volume function. So I write down this as v of x, and this equals 2x cube minus 26x squared plus 80x. Now we are going to find the first derivative of the volume function and find the critical numbers. So only at the critical numbers we can say that either the volume is maximum or volume is minimum. So our first task is to find the critical numbers. And we can find the critical numbers by setting up this equation, that is v prime of x equal to 0, and solving for x. So let's find the derivative of the volume function, that is v prime of x, and this equals the derivative of 2x cube is 6x squared, because the 3 will get multiplied with 2, and we reduce the power by 1. So 3 minus 2 is 1. And then the derivative of negative 26x squared is it is 26 times of derivative of x squared is 2x. So 26 times 2 is 52. So this becomes 52x. And finally, we have derivative of 80x is 80 times of derivative of x is 1. So this is basically 80. So we found the derivative of the volume function. Now we have to set this up equal to 0 and determine the value of x. So let's do that. I'm going to replace v prime of x equals 0, and this equals 6x squared minus 52x plus 80. Uh, we have a common term that we can divide. That is, we can divide by 2. So it becomes 0 equals 3x squared. I divide all the terms by 2, and this is 26x plus 40. Basically, we make a simplification from this equation to the next equation, so that we can easily determine the value of x. Now this is a quadratic equation. We can use the quadratic formula. So here a is 2. I'm sorry, a is 3. This the coefficient of x squared is a, and b is negative 26, and then c is 40. So we put this in quadratic formula. So therefore x equals, the quadratic formula is negative b plus minus of b squared minus 4ac under the root divided by 2a. So let's put this into this quadratic formula. So we put b is negative 26. So negative b will be positive 26 plus minus b squared, that is negative 26 quantity squared, minus 4 times of a is 3, and c is 40. This is under the root divided by 2 times of a is 3. So in the next step, we put this as 26 plus minus. Let's get this simplified by plugging into the calculator. And when I do that, I get 196. This is under the root divided by 2 times 3 is 6. So we will simplify this. This is 26 plus minus square root of 196 is 14 over 6. So we get two values of x, that is x equals 26 plus 14 over 6, or 26 minus 14 over 6. And this equals 26 plus 14 is 40 over 6, and this is 26 minus 14 is 12 over 6. So 40 over 6, we can divide both terms by the common factor, that is 2. So this becomes 20, and this is 3. So this is 20 over 3, comma 12 by 6 is 2. So we now have two values of x, that is, we have two critical numbers, and we have to prepare the sign chart so that we can determine at what critical number the volume function is maximum. So now that we have prepared we have found the critical numbers, we can prepare the sign chart for the v prime of x. So we have the critical numbers x equals 20 over 3. I'm going to write down this approximately as 6.67, and then the another critical number is 2. So we will create a number line. This 2 is less than 6.67, so I put 2 over here, and then 6.67, and then this is for the v prime of x. So we are going to determine the sign of v prime of x in the intervals. We have three intervals here, that is from negative infinity to positive 2, and then the second interval is 2 comma 6.67, and then greater than 6.67, that is 6.7 to infinity. So we will pick one random value in each interval, plug it into the v prime of x to understand its sign. So first let's check in this interval. I'm going to pick any value less than 2, which is I can pick 0 as well and plug it into this v prime of x. So v prime of x, when you apply, when you plug in 0, becomes 2 times of, this is 3 times of 0 square minus 26 times of 0 plus 40. So this is 0 and this is 0. We have 40, and this 2 is always positive, so we can just disregard it. We only have to understand the sign. So the sign here is positive number. So we put positive over here, and this means we can draw that it looks like an increasing function, and at 2 it becomes 0, that is the v prime of x is 0, which means it becomes flat. Now let's understand the sign in this interval, that is from 2 to 6.7. So once again we can pick some random values of x. Let's say that we pick x equal to 3 and plug it into the v prime of x. So therefore this becomes v prime of 3. This equals 2 times of 3 times of 3 squared minus 26 times of 3 plus 40. We put this expression into the calculator to understand its sign, and when we do that, we get this is found to be negative. So we get negative quantity. So we say that in this interval, the v prime of x is negative, which means it is sloping down. So we draw it like this. That is still this 6.67. We just okay. So here I have drawn this, and let's determine after this one. That is 6.67 to greater than 6.67. So we can pick some random numbers. That is, let's say that we pick 10. So this becomes a v prime of 10, and this equals 2 times of 3 times of 10 squared minus 26 times of 10 plus 40. We put this expression into the calculator, and we determine the sign, and this is found to be positive. We get that it is a positive number. So we simply put it is positive. So once again it is positive here, which means we can draw it like as such it is increasing. So clearly we can see that from this sign diagram, this is the slope is, that is the first derivative is increasing. The function is increasing, reaches the maximum value at when x equal to 2, and then it decreases. Here it is attaining minimum value. So we disregard this critical number. So we can now say that when x equal to 2, the volume is maximum. And we have shown this using the sign of v prime of x. And so we have answered the part B1. That is, we have determined the value of x where the volume is maximum, and we justified this by sign diagram. Now let's find the maximum volume. So to find the maximum volume, we have to plug this value of the critical number where the volume is maximum into the volume function. So I'm going to plug it x equal to 2 into the volume function. Let me copy the volume function, which is v of x, and this equals 2x cubed minus 26x squared plus 80x. I'm going to plug in x equal to 2 into this to determine the maximum volume. So it becomes v of 2, and this equals 2 times of 2 cube minus 26 times of 2 square plus 80 times of 2. 2 cube is 8. 8 times of 2 is 16, and 2 square is 4. So 26 times 4 is 104, plus 80 times 2 is 160. So 16 plus 160 is 176 minus 104. and this gives us 72. So therefore, we see that the maximum volume of the box is 72.